Tonight, we travel to one of the strangest moons in the solar system, a small frozen world orbiting Saturn, scarred by a colossal impact that should have destroyed it completely. Its giant crater is so large compared to the moon itself that it looks almost impossible, as if something struck Mimas with enough force to break it apart. But somehow, it survived. This is Mimas, the moon that carries the mark of a cosmic catastrophe, a silent, icy body drifting through Saturn's darkness, with one enormous wound staring into space like the eye of a world that refused to die. But the deeper scientists looked, the stranger Mimas became, because beneath its frozen surface, this dead-looking moon may be hiding something far more mysterious than anyone expected. Before we begin, write in the comments where you are watching from and what time it is in your country right now. And if you enjoy calm journeys into the mysteries of space, subscribe to Theories Before Sleep. Now, let us drift towards Saturn and discover the moon that survived a direct hit. Saturn has one of the most crowded and mysterious moon systems in the solar system. Around that enormous ringed planet, dozens upon dozens of worlds move through darkness. Some are large enough to have atmospheres, some are frozen and cracked, some hide oceans beneath their ice, some are only tiny fragments, captured stones moving in strange distant orbits. But among all of them, one moon stands apart almost instantly, not because it is the largest, not because it is the brightest, not because it has geysers, clouds, seas, or a thick atmosphere. It stands apart because the moment you see it, your mind reacts before the science even begins. It looks unreal. It looks designed. It looks like something from a movie. This is Mimas, a small icy moon of Saturn, only about 396 kilometers across, orbiting close to the planet compared with many of Saturn's other moons. It is one of the innermost major moons, a frozen little world circling a giant, surrounded by rings, shadows, and the pale golden light of a distant sun. And when people see Mimas for the first time, the reaction is almost always the same. It looks like the Death Star. That comparison is so obvious that even scientists have used it. The resemblance is not subtle. Mimas has one enormous circular crater dominating one side of its body, a dark hollow carved into the surface so perfectly placed and so absurdly large that the moon seems less like a natural object and more like a weapon of planetary destruction drifting beside Saturn. But Mimas is not a weapon. It is not some secret machine hidden among Saturn's moons. It is something even more fascinating. It is a survivor. The feature that gives Mimas its famous appearance is called Herschel crater. It is named after William Herschel, the astronomer who discovered Mimas in 1789. Herschel was already one of the great figures of astronomy, known for discovering Uranus and pushing human vision deeper into the solar system. But even he could not have known, when he discovered this faint little moon, what kind of scar it was carrying, because Herschel crater is enormous. It is roughly 139 kilometers across. On a moon only about 396 kilometers wide, that is almost impossible to look at without feeling that something went wrong. The crater is nearly 1/3 the diameter of Mimas itself. It is not just a surface mark. It is not a small dent from a passing stone. It is a wound so large that it seems to challenge the moon's survival. To understand how extreme that is, imagine the same proportions on Earth. If Earth carried a crater as large relative to its size as Herschel is on Mimas, that crater would stretch across a huge part of the United States. It would reach from around New York to Denver, covering states, mountains, rivers, cities, and landscapes beneath one colossal impact basin. That is the scale of the scar. Now imagine the impact that made it. A body from space, perhaps an asteroid or comet-like object, came rushing toward Mimas with enough speed to release a violence almost beyond imagination. In space, impacts do not need explosives to be catastrophic. Speed is enough. A relatively small object, moving fast enough, can deliver more energy than the surface of a moon can easily survive. When that object struck Mimas, it did not simply leave a mark. It nearly ended the moon. The collision blasted out a crater so wide that the entire body must have shaken. Shock waves would have traveled through the moon's icy interior. The surface would have cracked. Material would have been thrown upward and outward. The little moon would have trembled under a force so great that if the impact had been only a little stronger, Mimas might not exist today as a single world. It might have shattered. It might have broken into fragments. It might have become another cloud of debris orbiting Saturn. Just another broken memory among the rings and moons. But somehow, it held together. That is the mystery at the heart of Mimas. It should look like a survivor, and it does. It carries the evidence of a catastrophe right on its face. The crater is not hidden. It is not subtle. It is the first thing you notice. The entire identity of the moon seems shaped by one ancient moment when something tried to destroy it and failed. And this is what makes Mimas feel so strange. Many moons in the solar system are cratered. Our own moon is covered in impact scars. Mercury is marked by huge basins. Callisto, orbiting Jupiter, is one of the most cratered worlds we know. Craters are normal in space. They are part of the history of any solid world without weather, oceans, or active geology to erase them. But Herschel crater is different because of proportion. On a larger world, a crater like that would be impressive. On Mimas, it is almost absurd. It looks too big for the body that carries it. It feels like a mark from an event that crossed the line between damage and destruction. And yet, Mimas kept orbiting Saturn. The moon survived the impact. It continued moving around the planet. It continued reflecting the weak sunlight that reaches the outer solar system. It continued, silently carrying that enormous scar for millions, perhaps billions of years. When Voyager spacecraft first revealed Mimas more clearly, the comparison to the Death Star became impossible to ignore. Later, images from Cassini made the moon feel even more haunting. There it was, a pale icy sphere, cold and cratered, with one great hollow staring outward into space. Not smooth, not welcoming, not alive in the way Earth is alive, but not simple either. Mimas is a small moon, but its story is enormous. It is made mostly of water ice, with a low density compared with rockier worlds. That icy nature matters because ice behaves differently from rock under pressure, impact, and time. It can crack, deform, relax, and preserve scars in its own way. Mimas is not a massive world with strong gravity. It is only just large enough for gravity to pull it into a rounded shape. That detail is important. Mimas sits near the lower limit of what a world can be and still become rounded by its own gravity. It is not perfectly spherical like a polished marble. It is slightly stretched and imperfect, but it has crossed the line from irregular object to rounded moon. It is a small body that barely became a world in the shape we recognize. And that makes the Herschel impact even more dramatic, because Mimas was not a huge planet that could absorb a cosmic blow and continue easily. It was a tiny, icy body, only a few hundred kilometers across, with just enough gravity to hold itself together. When something struck it hard enough to carve out a crater nearly a third of its size, the entire moon was tested. Imagine a glass ball being hit so hard that one side collapses into a deep circular wound, but the ball does not fully break. That is Mimas, a world that seems to exist because the impact stopped just short of total destruction. The walls of Herschel crater rise high above the surrounding landscape. Its floor sinks deep below the surface. In the center, a mountain rises from the crater floor, formed by the rebound of material after the impact. This is common in large craters, but on Mimas, it feels especially dramatic because everything is scaled against such a small world. A central peak inside a crater that nearly destroyed a moon. A mountain at the center of a wound. A frozen memory of the moment Mimas almost came apart. If you could stand there, the view would be impossible to compare with anything on Earth. The gravity would be extremely weak. The horizon would curve close around you because the moon is so small. The crater walls would rise like ancient icy cliffs. Saturn would dominate the sky, enormous and golden, its rings cutting across space like a glowing blade. And beneath your feet would be a surface that survived one of the most violent events in its history. No wind would blow, no rain would fall, no rivers would carve the landscape. The crater would remain almost unchanged, preserved in silence, a record of impact frozen in time. That is why Mimas feels so ancient. It is not ancient in a calm way. It is ancient in a wounded way. Its surface tells a story of bombardment, cold, and survival. Every crater is a memory. Every mark is a record of something hitting the moon at high speed. But Herschel is the scar that overwhelms all the others. It is the event Mimas cannot hide. And perhaps that is why the moon captures attention so quickly. We are used to imagining space as beautiful, full of glowing nebulae, bright planets, and peaceful starfields. But Mimas reminds us that space is also violent. Small worlds do not always survive. Impacts do not always leave objects intact. Many bodies in the solar system have been shattered, rebuilt, scattered, or erased. Mimas survived by a fraction. That thought changes the way we see it. The Death Star comparison is fun, but it is also misleading if we stop there, because Mimas is not interesting only because it looks like something from fiction. It is interesting because nature created something that looks almost impossible. A tiny moon with an impact scar so large that it becomes a question written into ice. How did it survive? What was it like before the impact? What happened inside the moon when the shockwave passed through it? Did the impact crack the entire body? Did it change the orbit? Did it alter the interior forever? Could the same event that nearly destroyed Mimas also have helped shape the strange world we see today? These are the questions that turn a simple-looking moon into a mystery. For more than 2 centuries, Mimas has been known to astronomy, first as a faint moving point near Saturn, then as a world with shape, surface, and history. It began as something discovered through a telescope, a tiny companion of a distant planet. Over time, as spacecraft approached and cameras improved, it became more than a point of light. It became a place, a frozen world with geography, a moon with cliffs, craters, slopes, shadows, and a past. And Herschel crater became its signature. The more we learned about the moons of Saturn, the stranger Mimas seemed among them. Titan is enormous, wrapped in orange haze, with lakes and rivers made of liquid hydrocarbons. Enceladus is bright and active, spraying jets of icy material into space from a hidden ocean below. Iapetus has a strange two-tone surface, one side dark and one side bright. Hyperion looks like a sponge, full of bizarre pits and hollows. Saturn's moon system is filled with odd worlds, but Mimas is the one that looks like it almost did not make it. It is small, pale, and heavily cratered. It does not immediately show the dramatic activity of Enceladus. It does not have Titan's thick atmosphere. It does not glow with obvious signs of internal life. For a long time, it seemed like a frozen, battered, simple moon. A dead, little ball of ice. But sometimes, the most ordinary-looking worlds hold the deepest surprises. Mimas is a reminder that survival itself can be mysterious. A world does not need volcanoes or oceans on the surface to tell a powerful story. Sometimes, one scar is enough. One crater can reveal a whole violent chapter in the history of the solar system. The impact that created Herschel must have happened long ago, during a time when the Saturn system was still shaped by collisions, debris, and gravitational chaos. The object that hit Mimas is gone now. It was destroyed in the collision, its material mixed with the surface, or blasted into space. We cannot see it. We cannot know its exact shape. We cannot watch the impact happen. But the crater remains. The crater is the witness. It is the evidence left behind when the violence ended. And in a way, Herschel crater is not just a hole in the ground. It is a frozen explosion. It is the final shape of a moment that lasted perhaps only seconds, but changed the moon forever. The impact came. The surface broke. The shock traveled inward. The material rose and fell, and when everything settled, Mimas was still there, damaged, scarred, but whole. That is what makes this moon so fascinating. as a survival story. In the solar system, survival is not guaranteed. Planets form from collisions. Moons are shaped by impacts. Rings may come from broken bodies. Asteroids are fragments of larger things that never became worlds or were shattered after forming. Everywhere we look, the solar system carries evidence of destruction. But Mimas tells a very specific kind of story. It tells the story of almost destruction, not the end, not complete survival without damage, but the narrow space between those two. It is a moon that took a direct hit and remained a moon, a world that nearly became debris but stayed intact, a frozen body that should have been shattered yet continued orbiting Saturn as if refusing to disappear. And maybe that is why Mimas feels emotional, even though it is only ice and rock. We understand scars. We understand survival. We understand the idea that something can be marked forever by one event and still continue. Mimas carries that idea on a cosmic scale. Its entire face is a reminder that the universe can strike with unimaginable force, and sometimes, against expectation, something remains. Tonight, as we begin this journey, we are not looking at Mimas only as the Death Star moon. That nickname may be what makes people notice it, but it is not what makes it important. What makes Mimas important is what the nickname hides. Behind that familiar shape is a world at the edge of destruction, a moon barely large enough to be round, a body made mostly of ice, orbiting close to Saturn, marked by an impact that almost broke it apart. A place discovered in the 18th century, photographed by spacecraft centuries later, and still surrounded by questions today. How did Mimas survive? What happened inside it? What does Herschel crater reveal about the violence of Saturn's ancient system? And could this small, battered moon be more alive beneath the surface than it appears? Those questions will guide us deeper. But first, we have to sit with the image itself. A small moon in the darkness around Saturn. A huge crater dominating one hemisphere. A surface covered in ancient scars. A body that looks like a fictional weapon, but is really a natural survivor. Mimas is not frightening because it looks like the Death Star. It is frightening because the crater is real. The impact was real. Somewhere in the deep past, something hit this moon with enough force to nearly erase it from existence. The shock must have moved through its entire icy body. The surface must have split and lifted and collapsed. For a moment, Mimas may have been balanced between remaining whole and breaking apart forever. And then the violence ended. The debris settled. The moon continued. Saturn still pulled it through orbit, and the scar remained. That is the world we are entering tonight. Not a giant planet, not a famous moon with an atmosphere, not a bright ocean world spraying water into space, but a small, cold survivor with one of the most unforgettable faces in the solar system. The moon that looks like a machine of destruction. The moon that was nearly destroyed. The moon that should not have survived. This is Mimas. The face of Mimas is defined by one scar, not by mountains that rise across its surface, not by valleys that twist around its icy body, not by bright cracks, glowing geysers, or a thick atmosphere. One crater dominates everything. Herschel, a vast circular wound carved into the side of a moon that was almost too small to survive it. When you look at Mimas, Herschel is not just a feature on the surface. It is the surface. It is the first thing your eyes find, the thing your mind cannot ignore. The reason this little moon looks so strange, so artificial, and so impossible. The crater is about 139 kilometers wide. On Earth, that would already be enormous. But on Mimas, it becomes almost unbelievable. The entire moon is only about 396 kilometers across. That means Herschel stretches across nearly 1/3 of the moon's diameter. It is not like a crater on a world. It is more like a wound that nearly became the world itself. And it is not shallow. Herschel sinks about 5 kilometers deep into the icy crust. Its walls rise like frozen cliffs around the crater floor. At the center stands a peak, a mountain formed by the rebound of the surface after the impact, rising several kilometers from the crater floor. On a world as small as Mimas, that central peak feels almost impossible. A mountain inside a crater, a monument left behind by destruction, a frozen shape created in the seconds after something came screaming out of the darkness and struck the moon with enough force to nearly erase it from existence. The impact that created Herschel was one of the most violent events Mimas ever experienced. Scientists have tried to model what kind of object could have made a crater this large without completely destroying the moon. The answer is terrifyingly close to the limit. The object may have been around 10 kilometers across. That number matters because 10 kilometers is roughly the size of the asteroid linked to the extinction of the dinosaurs on Earth. On our planet, an impactor of that scale changed the course of life forever. It threw dust into the atmosphere, darkened the skies, triggered global destruction, and helped end the age of giant reptiles. But Earth is huge. Mimas is not. Mimas is tiny compared with Earth. It has far less gravity, far less mass, and far less ability to absorb a catastrophic impact. For a world only a few hundred kilometers across, being hit by an object around 10 kilometers wide is not just dangerous, it is almost fatal. The impactor would have approached at tremendous speed, perhaps tens of kilometers per second. In space, speed is everything. A rock does not need to be glowing or explosive to become a world-ending force. It only needs mass and velocity. When something that large moves that fast, it carries an amount of kinetic energy that is almost impossible to imagine. Then it struck Mimas. In one instant, the quiet surface of the moon became the center of a cosmic explosion. There would have been no air to carry sound, no atmosphere to burn the object apart before it arrived, no weather to soften the violence. The impactor would have slammed directly into ice and rock, releasing its energy almost instantly. The surface would have compressed, fractured, vaporized, and blasted outward. For a moment, Herschel crater was not a crater. It was a rising storm of shattered ice. Material from the surface would have been thrown high above the moon. Some pieces may have escaped into space. Others would have arced outward and fallen back across the surface. A glowing cloud of debris may have expanded around Mimas, briefly turning the small moon into something between a world and the wound. From far away, perhaps from the orbit of Saturn itself, the impact would have looked like a sudden flash. A cold little moon, silent for ages, suddenly lit by violence. A burst of light on the side of Mimas, a spray of debris. A moment where the moon's survival was not guaranteed, and then the shockwave began to move. This is the most frightening part of the Herschel impact. The energy did not stay at the surface. It traveled through Mimas. The entire moon would have shaken from the force. Shock waves would have passed through its interior, racing through ice and rock, carrying the memory of the impact from one side of the body to the other. On a large planet, an impact can be devastating and still feel local compared with the size of the world. But Mimas is so small that the impact was global. The whole moon felt it. The surface around the crater fractured. The crust bent and broke. The shock moved inward through the body of the moon and emerged on the opposite side. And there, on the far side of Mimas, the terrain is strange and chaotic, marked by fractures that may have been caused by the same event. This is not just a crater story, it is a whole moon story. The object hit one side of Mimas, but the damage reached far beyond the impact site. It may have cracked the opposite hemisphere. It may have disturbed the internal structure. It may have reshaped the stress patterns of the entire icy body. Imagine striking a small frozen sphere with a hammer so hard that the other side begins to crack. That is the kind of violence Mimas survived. And the word survived is important because this impact was right at the boundary between survival and destruction. If the impactor had been larger, Mimas may have shattered. If it had been faster, Mimas may have shattered. If the angle had been different, if the moon's internal structure had been weaker, if the energy had crossed the threshold by even a small amount, the story might have ended there. There would be no Death Star moon today, no Herschel crater staring out into space, no small round world orbiting Saturn with a wound almost too large to believe. Instead, there may have been debris, fragments, a broken cloud of ice and rock spreading around Saturn. Perhaps some of that material would have fallen into new orbits. Perhaps some would have drifted toward the rings. Perhaps some would have collided with other moons or been pulled apart by Saturn's gravity. Mimas might have become another ghost in the history of the Saturn system, a world that formed, lived briefly in cosmic time, and then was destroyed. But that did not happen. The impact came almost to the maximum Mimas could survive, and somehow the moon remained whole. This is why Mimas can be seen as one of the luckiest moons in the solar system. Not lucky in a gentle way, not lucky because it avoided destruction. It did not avoid anything. It was struck directly. It was scarred forever. It was wounded so deeply that its entire identity changed. But it was lucky because the impact stopped just short of ending it. The universe came close to erasing Mimas and missed by the smallest margin. When we look at Herschel crater today, we are not just seeing a hole, we are seeing the boundary line between existence and destruction. We are seeing the frozen result of an event that almost turned a moon into a ring of fragments. That is what makes Herschel so powerful. Its size is not only impressive, it is meaningful. It tells us that Mimas experienced an impact near the limit of what a small icy world can endure. The crater is a record of energy, force, survival, and chance. And chance matters in the solar system. The moons and planets we see today are not just the result of calm formation. They are the survivors of countless violent events. Impacts built worlds. Impacts shattered worlds. Impacts changed climates, tilted axes, carved basins, formed moons, and perhaps delivered ingredients needed for life. The solar system is peaceful only from a distance. Up close, it is a history of collisions. Mimas carries that history openly. There is no atmosphere to hide it, no rain to soften it, no oceans to erase it. No active surface process is strong enough to completely smooth away the past. The crater remains, preserved like a fossil of violence, a memory written into ice. And because Mimas is so small, Herschel makes the moon feel personal in a strange way. On a giant world, an enormous crater can still become part of a much larger landscape. On Mimas, Herschel becomes almost the face of the moon. It gives the moon expression. It makes it feel wounded, watchful, unforgettable. That is why people compare it to the Death Star. The crater looks like the dish of a planet-destroying weapon. The icy sphere looks like a machine from science fiction. The resemblance is so strong that it can be hard to see Mimas as a natural moon at first. Your brain wants to turn it into something built, but nature does not need design to create impossible shapes. All it needed was one impact. One object, one collision, one moment when the speed and mass of a wandering body were converted into a scar that would last for ages. The irony is that the feature that makes Mimas look artificial is actually proof of how natural and violent it is. Herschel crater does not show design, it shows survival. After chaos, it shows that small worlds live in danger, especially in the early solar system, when debris moved everywhere and collisions were far more common. The object that hit Mimas is gone now. It was destroyed in the impact. Its body became part of the explosion, part of the crater, part of the debris cloud. Some of its material may still be mixed into the surface. Some may have been launched into orbit around Saturn. Some may have escaped the moon entirely. In that sense, Herschel is also a grave, a trace of the object that created it. The impactor no longer exists as a separate thing, but its violence remains visible. It lives on as a crater, as fractures, as a changed landscape, as a story frozen into the side of Mimas. What would that moment have looked like from Saturn? Imagine floating above the rings, looking outward toward a small icy moon. Saturn fills part of the sky, huge and golden. Its rings stretch like glowing arcs through darkness. Mimas is small, pale, and quiet, moving along its orbit like it has done for ages. Then, suddenly, light, a flash erupts on one side of the moon. For a few seconds, Mimas becomes brighter, not from sunlight, but from impact. The collision releases heat, vapor, shattered ice, and expanding debris. A cloud rises from the surface and spreads outward. Fragments escape, sparkling briefly in the cold light. The moon trembles. The far side cracks. The entire body is shaken by the blow. From a distance, it might look almost beautiful, but beauty in space can be misleading. That flash would have been destruction, a near ending, a violent test of whether Mimas would remain a moon at all. Some of the material blasted from the crater may have fallen back, covering parts of the surface with ejecta. Some may have escaped Mimas's weak gravity. Because the moon is so small, it does not hold on to debris the way a planet does. Fragments launched fast enough could leave forever, entering orbit around Saturn or becoming part of the complex debris environment around the planet. It is possible that impacts like this contributed material to the Saturn system. Over time, tiny grains, ice fragments, and debris could be scattered, pulled, shaped, and redistributed by Saturn's gravity and the motion of nearby moons. Around a planet with such an enormous ring system, every piece of icy debris becomes part of a larger story. Mimas itself is connected to Saturn's rings in subtle ways. Its gravity helps shape gaps and waves in the rings, influencing the structure of material far beyond its own small size. So this tiny moon is not isolated. It lives inside a gravitational system of rings, moons, particles, and resonances. The Herschel impact may have been one violent event, but its consequences may have reached beyond the moon. A crater on Mimas, a debris cloud around Saturn, material escaping, falling back, or joining the wider dance of the ringed planet system. One collision spreading its influence through space. And then, after the violence, silence returned. The debris settled. The surface cooled. The crater remained. Mimas continued around Saturn, carrying the wound forward through time. That is one of the haunting things about impact craters. The event that creates them is sudden, but the scar can last for billions of years. A few seconds of violence can become a permanent feature of a world. The collision ends almost instantly, but the surface remembers. Mimas remembers Herschel. It remembers in the only way a moon can remember: through shape, through fracture, through shadow, through the enormous circular basin that still dominates its face. When sunlight hits Mimas at the right angle, Herschel becomes dramatic. The crater walls cast shadows. The central peak rises from the floor. The rounded body of the moon curves away into darkness. The whole scene feels like a frozen moment from the aftermath of disaster. It is not hard to imagine why people are drawn to it. There are many moons more scientifically famous than Mimas. Titan has atmosphere and methane lakes. Enceladus has icy jets and a hidden ocean. Europa, around Jupiter, may contain one of the best environments for life beyond Earth. Ganymede is the largest moon in the solar system, but Mimas has a simpler, sharper mystery. It was hit. It should have broken. It did not. That story is easy to understand and hard to forget. And beneath it lies a deeper question. What does it take to destroy a moon? Not a planet, not a comet, not an asteroid. A moon. How much force must be delivered before gravity can no longer hold the body together? How large can a crater become before the entire world fails? How close can a moon come to destruction and still remain intact? Mimas gives us a natural experiment, a real example of a world struck near the edge of survival. Scientists can model the impact, estimate the size and speed of the object, study the crater, examine the fractures, and compare the result with what physics predicts. Herschel is not just visually strange. It is a clue to the strength, structure, and history of Mimas itself. The crater tells us something about the moon's interior. If Mimas had been too fragile, it might have shattered. If its structure had been different, the crater might have looked different. If the ice had behaved differently under stress, the shock might have spread in another way. The fact that Mimas survived gives scientists a way to understand how small icy worlds respond to extreme impacts. In this sense, Herschel is not only a wound, it is a laboratory, a record of one of the most extreme survivable impacts in the Saturn system. And yet, when we speak about it at night, in the calm darkness of a space documentary, it becomes more than science. It becomes an image of persistence, a small world, almost broken, still circling a giant planet, a moon carrying a scar so large it should not look whole, a reminder that the solar system is filled with objects that survived events we can barely imagine. The impact that formed Herschel did not make Mimas famous in its own time. No one was there to see it. No ancient observer on Earth looked up and noticed a flash near Saturn. No telescope existed to capture it. The event happened in silence, long before human eyes could understand what was happening in the outer solar system. For ages, the crater waited. Mimas continued to orbit Saturn. The rings shone beside it. Other moons moved around it. The sun rose and set across its icy surface again and again, though each day there would have been nothing living there to see it. Then, much later, humans built telescopes, then spacecraft, then cameras strong enough to see the scar. And when we finally looked closely, Mimas revealed what had been waiting all along, a crater so large that it changed the meaning of the moon. That is what Herschel does. It turns Mimas from a small icy satellite into a survival story. Without Herschel, Mimas might be one more frozen moon among many. Interesting. Yes, but perhaps not unforgettable. With Herschel, it becomes one of the most recognizable worlds in the solar system. It becomes the moon that looks like the Death Star, the moon that survived the direct hit, the moon that came close to becoming debris and somehow held together. The crater defined the moon and almost ended it. That is the strange contradiction at the heart of Mimas. The thing that nearly destroyed it is the thing that made it famous. The wound became its identity. The scar became its face. And every time we look at it, we are looking at a frozen boundary between life and disappearance. Not biological life, but the life of a world. As a world, the difference between remaining whole and becoming fragments. The difference between a moon with a name and a lost cloud of debris around Saturn. Mimas remained whole, but only just. Somewhere in its distant past, a 10-kilometer object crossed its path. It struck at enormous speed. It carved a basin 139 kilometers wide and 5 kilometers deep. It raised a central peak from the crater floor. It sent shockwaves through the entire moon. It fractured the far side. It threw debris into space. It brought Mimas to the edge of destruction. And then the moon survived. That is why Herschel Crater is more than a feature. It is the moment Mimas almost ended. It is the proof that the universe can strike with nearly unbearable force. And it is the reason this small icy world still feels so mysterious, so cinematic, and so alive in the imagination. Because every time Mimas turns through Saturn's sky, its scar turns with it. A frozen eye, a wound in ice, a crater that says, silently and forever, this moon should have died. But it did not. For decades, Mimas was almost ignored. Among Saturn's moons, it did not seem like the place where anything important would be hiding. Titan had its thick, orange atmosphere. Enceladus had its icy geysers spraying material into space. Iapetus had its strange two-colored surface. Hyperion looked like a sponge drifting through the dark. But Mimas looked simple, small, frozen, battered, dead. It was the moon with the giant crater, the one everyone compared to the Death Star. It was interesting to look at, but for a long time, many scientists thought they understood the basic story. Mimas was an old icy body, scarred by impacts, orbiting Saturn with nothing especially active happening inside it. No plumes, no great cracks, no fresh icy plains, no sign that the moon was changing. It looked like a cold ball of ice that had suffered one enormous impact and then spent the rest of its life quietly circling Saturn. And for a long time, that was the story. Mimas was not the first place anyone expected to find something alive in a geological sense. It was not the first place anyone expected to find movement, warmth, or hidden activity. If scientists were searching for secret oceans, they looked elsewhere. They looked at worlds that already showed signs of internal energy. They looked at Enceladus, with its bright fractures and water-rich jets. They looked at Europa, cracked and pulled by Jupiter's gravity. They looked at Titan, with its chemistry and atmosphere. Mimas seemed like the opposite of all of that. A fossil, a frozen relic, a moon that had survived a terrible impact but had nothing left to reveal. Then everything changed. The surprise did not come from a new spacecraft flying past Mimas. It did not come from a lander touching the surface or a camera seeing geysers erupting from the ice. It came from old data collected by the Cassini spacecraft during its long mission around Saturn, and then studied again with new techniques. Sometimes space discoveries happen like that. A spacecraft sends back information. Scientists study it. Years pass, new models improve, new questions are asked. Old measurements become useful in ways no one fully understood at the time. And suddenly, something that looked ordinary becomes impossible to ignore. That is what happened with Mimas. Researchers looked closely at the way the moon moves as it orbits Saturn, not just where it is, not just how fast it travels, but how it wobbles. This wobble is called libration. It is a slight rocking motion, a subtle back and forth movement as the moon travels around its planet. To us, it may sound small, almost unimportant, but in planetary science, a tiny wobble can reveal the deep interior of a world. A moon is not only judged by its surface, it is also judged by how it moves. If a moon is solid all the way through, it should wobble in one kind of way. If it has a strange core, or a hidden layer, or a liquid interior beneath its crust, it may wobble differently. Its outer shell may move slightly out of step with what lies beneath it. Its motion can betray secrets that its surface refuses to show. And Mimas was wobbling too much. The motion could not be easily explained by a simple frozen body with a fully solid interior. Something about the way Mimas rocked in its orbit suggested that the inside was not as dead and rigid as the outside appeared. Something inside Mimas was moving, something liquid, and the conclusion was almost shocking. Mimas may have a hidden ocean beneath its frozen surface, a global ocean of liquid water, not on Titan, not on Enceladus, not on Europa, but on Mimas, the moon that looked like a dead ice ball, the moon with no geysers, no young surface, no dramatic signs of activity, the moon that seemed too small, too cold, and too damaged to hide anything like this. Beneath its icy shell, perhaps 20 to 30 kilometers below the surface, there may be liquid water wrapped around the moon's interior, an ocean hidden so well that, for decades, almost no one expected it to be there. That is what makes this discovery so powerful. Mimas did not look like an ocean world. It looked like the opposite of one. When we imagine a moon with an ocean, we often expect clues on the surface: cracks, ridges, smooth plains, fresh ice, eruptions, plumes, some kind of sign that the inside is warm enough, active enough, alive enough to reshape the outer shell. Enceladus gives us those signs clearly. Its south pole is cracked and active. Jets of water-rich material rise into space. Its ocean announces itself. Mimas does not. Mimas hides. Its surface looks old and heavily cratered. Herschel crater still dominates one side. Smaller impact scars cover the rest. There are no obvious plumes spraying from cracks, no fresh bright bands cutting across the surface, no dramatic geological activity calling attention to what lies below. That is why nobody expected it. The surface told one story, the motion told another. And in space, sometimes the motion is more honest than the surface. If Mimas truly has a subsurface ocean, then it is one of the most unexpected ocean worlds ever discovered. It means that a moon can look dead on the outside while hiding liquid water inside. It means that the signs of an ocean may be much more subtle than scientists once thought. It means that other small icy moons, dismissed as frozen and inactive, may deserve a second look. This changes the way we think about the solar system. For a long time, oceans beyond Earth seemed rare. Then we began to realize that liquid water may be hidden inside many icy worlds, not on the surface where it would freeze or escape, but below thick shells of ice, protected from space, warmed by gravity, and kept liquid in darkness. The solar system may be filled with hidden oceans, not blue oceans under open skies like Earth's, but black oceans, silent oceans, oceans beneath ice, where sunlight never reaches, where the surface above may look dead for billions of years, while deep below, water quietly moves. Mimas may be one of those worlds, and perhaps the strangest thing is how young its ocean may be. Scientists studying the data suggested that the ocean inside Mimas may not have been there for most of the moon's history. It may have formed relatively recently. In geological terms, perhaps only millions of years ago. That is almost yesterday for a moon. The solar system is about 4.6 billion years old. Saturn and its moons formed in deep ancient time. The cratered surface of Mimas looks like it belongs to that old, battered history. And yet, hidden below it, there may be an ocean that is young. Young enough that the surface has not had time to fully react. That may explain the great mystery. Why does Mimas not look active if it has an ocean? Because the ocean may be new. If liquid water formed beneath the ice only recently, then the surface may not yet show the dramatic signs we would expect. The ice shell may still look ancient. The craters may still be preserved. The outer face of the moon may not yet have been cracked, resurfaced, or transformed by the ocean below. The inside changed before the outside could reveal it. This is one of the most beautiful ideas in the story of Mimas. A moon can keep an old face while hiding a young secret. On the surface, Mimas looks ancient, wounded, and still. But deep below, something may have awakened. A hidden ocean may have formed beneath the ice, quietly and recently, without announcing itself with geysers or fractures. The moon did not change its appearance. It did not erupt. It did not shine. It simply began to move differently. A wobble, a small rocking motion. That was the clue. Not a plume rising into space, not a bright new terrain. A wobble. The whole moon gently revealing that something inside it was not frozen solid. And the reason that ocean may exist comes back to Saturn. Mimas orbits a giant planet. Saturn's gravity is enormous. As Mimas travels around it, the moon is pulled and flexed. The strength of that pull can change slightly during the orbit. Over long periods of time, that repeated flexing can generate heat inside a moon. This is called tidal heating. It is one of the most important processes in the outer solar system. Far from the sun, sunlight is weak. Small icy moons should be frozen solid, but gravity can replace sunlight as a source of warmth. A giant planet can squeeze a moon again and again, gently deforming it, creating friction and producing heat inside. That heat can keep oceans liquid beneath ice. It happens with Europa around Jupiter. It happens with Enceladus around Saturn. And now, it may be happening with Mimas, the same moon that looks cold, dead, and quiet, may be warmed from within by Saturn's pull. Every orbit, Saturn's gravity tugs on Mimas. The moon responds. Its icy body flexes. The interior is stressed. Over time, energy is converted into heat. Enough heat, perhaps to melt part of the interior ice and create a global ocean beneath the shell. This is not a dramatic kind of heat. It is not fire. It is not a glowing core like the center of Earth. It is slow, hidden, mechanical warmth created by gravity itself. A moon being squeezed into secrecy. And that makes Mimas feel almost impossible. The Death Star moon, famous for its enormous crater, may also be an ocean world. The same body that looks like a frozen weapon from science fiction may be carrying liquid water beneath its scarred surface. That contrast is what makes the discovery so powerful, because Mimas is not the kind of world that should surprise us this way. It was supposed to be simple. It was supposed to be a battered ice ball. It was supposed to be a moon whose most interesting event happened long ago, when Herschel crater was carved into its face. But now, the story is different. Mimas is not only a survivor of an ancient impact, it may be a world in transition, a moon whose interior is changing while its surface still looks frozen in the past. And that raises a fascinating question. If Mimas has an ocean, what will it look like in the future? Will the surface eventually crack? Will the ice shell shift? Will new terrain appear? Could Mimas someday begin to resemble Enceladus, with fractures and activity revealing what lies below? Or will its ocean remain hidden, locked beneath the surface, silent for millions of years? We do not know. That uncertainty is part of the mystery. Mimas may be showing us an early stage in the life of an ocean world, a moment before the surface changes, a stage where the ocean has formed, but the outer ice has not yet responded in obvious ways. It may be like seeing the beginning of a story that is usually hidden from us. Most ocean worlds we study may already be mature. They already show cracks, jets, or reshaped surfaces. Mimas may be different. It may be young. It may be an ocean world before the reveal. If that is true, then Mimas becomes scientifically precious. It could help scientists understand how subsurface oceans begin, how tidal heating changes small icy moons, and how long it takes for internal water to affect the surface. It could help answer questions about other worlds too. How many moons might hide young oceans? How many bodies have been dismissed because their surfaces look too old? How many quiet, icy objects are secretly changing inside? The solar system may have more hidden water than we imagine, and Mimas, of all places, may be one of the keys. But the discovery also makes Herschel crater more mysterious. That enormous impact almost destroyed the moon. It sent shockwaves through the body. It fractured the surface. It changed Mimas forever. If there is now an ocean beneath the ice, scientists must ask how that ocean relates to the crater and the moon's internal history. Was Mimas fully frozen when Herschel formed? Did the impact affect the interior in ways that later mattered? Could the shock have weakened the ice, altered the structure, or changed how heat moved through the moon? Or is the ocean much younger, formed long after the impact, with Herschel remaining as an old scar above a newer hidden sea? The answers are not simple, but the combination is incredible. A moon with one of the largest impact scars in proportion to its size may also have a young ocean beneath its surface. That means Mimas is both ancient and young. Ancient on the outside, young on the inside. A moon that carries the memory of a violent past while hiding evidence of a surprising present. This is why Mimas changed from boring to extraordinary, almost overnight. For decades, it was the strange little Death Star moon, a curiosity, a battered object, a world that looked interesting mainly because of one crater. Then the data was re-examined, the wobble was measured, and the meaning changed. Suddenly, Mimas was not just a moon with a scar, it was a moon with a secret. And that secret was water. Liquid water is one of the most important substances in planetary science. On Earth, it is tied to life, chemistry, geology, and climate. Beyond Earth, every time we find evidence of liquid water, we pay attention. Not because water automatically means life, but because water creates possibility. It creates movement. It creates chemistry. It creates environments where complex processes can happen. A hidden ocean on Mimas does not mean life exists there. The moon may not have the right chemistry, the right energy, or enough time. Its ocean may be too young, too isolated, or too limited in ways we do not yet understand. But the discovery still matters, because it expands the category of worlds that can hide liquid water. It tells us that even a small, cratered, apparently dead moon can be more complex than it looks. And it reminds us that appearances in space can be deeply misleading. Mimas looked dead. Its surface looked ancient. Its giant scar looked like the main story. But beneath that frozen shell, something may be moving. A global layer of water wrapped around the moon's interior, hidden under tens of kilometers of ice, kept liquid by the slow gravitational pressure of Saturn. No waves under an open sky, no sunlight touching the surface, no wind, no blue horizon, only darkness beneath ice. A silent ocean inside a moon that nobody expected to be alive in any geological way. That image changes Mimas completely. The Death Star moon becomes an ocean moon. The boring moon becomes one of the biggest surprises in planetary science. The scarred survivor becomes a hidden world, and maybe that is the lesson Mimas gives us. In the solar system, the most interesting places are not always the obvious ones. Sometimes the quiet world matters. Sometimes the battered moon has the secret. Sometimes a place that looks dead is only waiting for us to measure it carefully enough. Mimas did not announce its ocean. It whispered it through motion, through a wobble, through a slight rocking in its orbit around Saturn. And that tiny movement was enough to change its entire identity. Now, when we look at Mimas, Herschel crater is still there. The moon still looks like the Death Star. It still carries the wound of the impact that almost destroyed it. It still appears cold and ancient from the outside, but we see it differently. We imagine the ice shell. We imagine the darkness below. We imagine a hidden ocean, young and silent, wrapped around the moon's interior. We imagine Saturn's gravity squeezing the moon gently, orbit after orbit, creating just enough heat to keep water liquid beneath the frozen crust. And suddenly, Mimas no longer feels like a dead object. It feels like a secret still being uncovered, a moon that fooled us for decades, a moon that looked finished but was not, a moon that survived a direct hit, carried its scar through time, and then revealed that beneath the damage, something may still be moving. This is the ocean nobody expected, and it may be the greatest surprise Mimas has ever given us. The moment scientists began to suspect that Mimas had an ocean, the question changed immediately. It was no longer just a moon with a giant crater. It was no longer just the Death Star moon. It was no longer just a frozen survivor of a catastrophic impact. It became something far more interesting and far more mysterious. Because wherever liquid water appears in the solar system, one question always follows. Could anything live there? That question is not simple. It is not something we can answer just because water exists. Water matters, but water alone is not enough. A world can have water and still be lifeless. It can have an ocean and still be chemically poor, too young, too cold, too isolated, or too lacking in energy for biology to begin. But still, the question cannot be avoided. If Mimas really has a global ocean hidden beneath its ice, then somewhere below that scarred and silent surface, there may be a dark sea wrapped around the moon's interior. No sunlight, no open sky, no waves beneath Saturn's pale glow, only liquid water, sealed under perhaps 20 to 30 kilometers of solid ice, moving in darkness inside one of the least expected worlds in the solar system. And that changes everything. For decades, Mimas looked dead. It looked like a body whose most important story had already happened long ago, when the Herschel impact nearly destroyed it. Its surface was old, cratered, frozen, and quiet. There were no geysers like Enceladus, no long global cracks like Europa, no thick atmosphere like Titan, no obvious signs that anything inside it was warm or moving. If you had asked where to look for life around Saturn, Mimas would not have been the first answer. It might not even have been the 10th. And yet, beneath that frozen crust, there may be water, a hidden ocean, a secret sea inside a moon that looked completely finished. So we have to ask the question carefully. Could life exist in Mimas's ocean? To answer that, we have to begin with what life, as we understand it, seems to need. The first requirement is liquid water. On Earth, life is connected to water everywhere we find it. In oceans, lakes, rivers, ice, deep rocks, and microscopic cracks beneath the surface, water is the medium where chemistry can move, react, dissolve, transport, and change. Without liquid water, the chemistry of life becomes much harder. Mimas may have that first ingredient, not on the surface, where the cold of space would freeze it almost instantly, but below the ice, protected from the vacuum, shielded from radiation, hidden beneath the shell thick enough to preserve the ocean from the outside universe. That alone is remarkable. A moon that looks like a dead ice ball may contain the first great requirement for life. But life also needs chemistry. It needs building blocks: carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur, elements that can form complex molecules, carry energy, build structures, and create the chemistry needed for living systems. In the outer solar system, many of these elements are not rare. Icy moons are not made of pure water ice alone. They often contain rock, salts, organics, and other compounds mixed into their interiors or surfaces. Around Saturn, especially, the moon system contains a variety of materials shaped by ancient formation, impacts, and interactions between worlds. Mimas likely contains at least some of the basic ingredients. Its icy body, like other outer solar system moons, is not isolated from cosmic chemistry. It has been struck by debris over time. It formed from material in Saturn's system. It may contain rocky components beneath its icy exterior, and if a liquid ocean is in contact with a rocky interior, that becomes very important, because water and rock together can create chemistry. On Earth, some of the most interesting environments for life are not sunlit beaches or warm, shallow seas. They are deep ocean hydrothermal vents, places where seawater moves through the crust, reacts with hot rock, and returns rich in chemicals. Around these vents, life survives without sunlight. It does not depend on photosynthesis. It depends on chemical energy. This was one of the great discoveries that changed how scientists think about life in the universe. Before we understood deep-sea ecosystems, it was easy to imagine that life needed sunlight. Earth's surface life depends heavily on the sun. Plants use sunlight. Animals depend on plants or other organisms that depend on them. Most familiar food chains begin with light. But deep in Earth's oceans, in complete darkness, life found another way. There, chemical reactions provide energy. Microbes use compounds from the vent fluids. Larger organisms depend on those microbes. Entire ecosystems exist in a world where sunlight never reaches. That matters for icy moons, because beneath the ice of Europa, Enceladus, and perhaps Mimas, there is no sunlight. If life exists there, it probably cannot depend on light from the sun. It would need chemical energy from the moon itself. So the key question becomes this: does Mimas have an energy source strong enough, steady enough, and long-lasting enough to support life? This is the critical unknown. Mimas may have water. It may have chemical building blocks, but without usable energy, an ocean can remain sterile. A dark sea can sit beneath ice for millions of years without ever becoming alive. Life does not simply appear because the ingredients are present. The ingredients need to be driven, mixed, activated, and sustained. This is where Mimas becomes difficult. Its ocean may be young, very young, perhaps only 5 to 15 million years old. That sounds ancient. From a human point of view, 5 million years is longer than recorded history, longer than civilizations, longer than modern humans have existed as we know ourselves. But in geological time, it is almost nothing. Earth is billions of years old. Life on Earth emerged very early in the planet's history, but still across timescales far longer than human history can easily hold. The origin of life is not fully understood, but it involved complex chemistry, environmental stability, energy sources, and time. Mimas's ocean may simply not have had enough time. That is the pessimistic answer. If the ocean formed only recently, then even if the conditions are interesting, life may not yet have had a chance to begin. The chemistry may still be young. The environment may not have stabilized. The ocean may be in its earliest stage, not yet mature enough to support biology. On Earth, life did not appear in a moment that we can easily explain. It was not as simple as water plus rock plus heat equals life. The beginning of life remains one of the deepest scientific mysteries we have. We know life emerged. We know it transformed our planet. But the exact path from chemistry to biology is still being studied. So when we look at Mimas, we have to be careful. A hidden ocean does not mean life. A young ocean especially does not mean life. Mimas may be habitable in some basic sense, but habitability is not the same as being inhabited. There is a difference between a place where life could possibly exist and a place where life actually does exist. Mimas may be at the beginning of that question, not the end. But the optimistic answer is still powerful, because the ingredients may be there. Liquid water, basic chemistry, internal heat from tidal forces, a protected environment beneath the ice, a world where the surface may look frozen and dead, but the interior may be more active than anyone imagined. If Mimas's ocean persists for hundreds of millions of years, the question becomes more open. If tidal heating continues, if the ocean remains liquid, if water interacts with rock, if chemical energy is available, then the possibility of life cannot be completely dismissed, not because we expect forests, animals, or anything complex. That is not the kind of life scientists are imagining. If life ever emerged in Mimas's ocean, it would most likely be microbial, tiny, simple organisms using chemical energy in darkness. Life that would never see the stars, life that would never know Saturn was above it, life sealed inside a moon that, from the outside, looks dead. That idea is strange and beautiful. A moon with a giant crater, famous because it resembles a fictional weapon, may also contain a hidden environment where chemistry could one day become biology. Not now, perhaps. Not yet. But maybe, if time is kind, the real challenge is the ocean floor. For life as we know it, one of the best possibilities would be interaction between the ocean and a rocky core. If liquid water touches rock, chemical reactions can occur. Minerals can dissolve. Heat can drive circulation. In the right conditions, something like hydrothermal activity might exist. But do we know that Mimas has hydrothermal vents? No, that is still unknown. Mimas is small, and its internal structure is not understood as well as worlds like Enceladus. Enceladus gives us direct evidence from its plumes, where material from the ocean is sprayed into space. Scientists can study those plumes and look for salts, organics, and other signs of chemical activity. Mimas gives us no such gift. Its ocean, if present, is hidden completely. No plumes, no fresh material thrown into space, no easy sample. That makes it far harder to know what is happening below. There could be an ocean under the ice, but it might not be in strong contact with a rocky seafloor, or it might be separated by layers of high-pressure ice or other structures, or it might touch rock but lack enough heat and chemistry to create rich energy sources. We do not yet know. That uncertainty keeps the life question open, but cautious. Mimas has moved onto the list of worlds that matter for astrobiology, but it is not suddenly the best candidate for life. It is not more promising than Enceladus, which is actively sending ocean material into space. It is not more obvious than Europa, whose cracked surface points to deep internal activity. It is not like Titan, with its extraordinary chemistry and atmosphere. Mimas is different. Its importance is not that it is the most likely place to find life. Its importance is that it was the least expected place to find an ocean. That is the revolution. For years, scientists built categories in their minds. Some worlds looked alive. Some were worth studying for habitability. Others seemed like frozen leftovers. Mimas breaks that simple pattern. It says that a world can look dead and still hide liquid water. It says that the surface may lie. It says that the solar system may be full of secret oceans, hidden beneath ice, on worlds nobody used to take seriously. And that changes the search for life. Because if Mimas can have an ocean, then what else are we missing? How many small icy moons around Saturn, Uranus, and Neptune might contain hidden layers of liquid water? How many distant objects in the outer solar system might have internal oceans kept alive by tidal heating, radioactive decay, antifreeze-like chemistry, or ancient trapped heat? How many worlds have we dismissed because their surfaces looked too quiet? The discovery of ocean worlds has already changed planetary science. Europa, Enceladus, Ganymede, Titan, Callisto, Triton, and other icy bodies have all become part of a much larger story. The outer solar system is not simply a frozen graveyard. It may be a region where water hides under ice, where warmth is created by gravity, and where chemistry continues far from the sun. Mimas joining that story is almost shocking, because Mimas was supposed to be boring, and that is exactly why it matters. It forces us to widen the search. It tells us that habitability may not always be obvious. A world does not need a dramatic surface to have a complex interior. It does not need plumes to be interesting. It does not need to advertise its ocean. Sometimes, the only clue may be a wobble in its orbit, a slight motion, a subtle measurement, a quiet hint that the inside is not solid. This is how the solar system becomes stranger. The more we study it, at first, planets were points of light. Then they became worlds. Then moons became worlds. Then icy moons became ocean worlds. And now even one of the most unlikely moons around Saturn may be hiding a sea. The search for life is no longer only about planets like Earth. It is about hidden environments, dark oceans beneath ice, chemical energy instead of sunlight, small moons instead of large worlds, places that look dead from the outside but may be quietly active within. that does not mean the solar system is filled with life. We have not found life beyond Earth. Not yet. But the number of places where life could possibly begin has grown far beyond what earlier generations imagined. The habitable zone is no longer just a ring around a star where surface water can exist. There may also be deep habitable zones inside icy worlds, warmed by gravity, shielded by ice, and hidden from the universe above. Mimas may be part of that hidden geography of life, a dark ocean sealed under ice, orbiting Saturn. Maybe sterile, maybe too young, maybe waiting. The idea that its ocean may be only a few million years old makes it especially fascinating. If true, Mimas might show us what an ocean world looks like near the beginning of its life. Not a mature ocean world with cracks and plumes, but a young one, still hidden, still quiet, still not fully visible on the surface. That could teach us about the stages of habitability. Perhaps oceans are born inside icy moons more often than we think. Perhaps they grow, evolve, interact with rock, change the crust, and eventually reveal themselves. Perhaps Enceladus is a later stage, where the ocean has become active enough to break through the surface. Perhaps Mimas is an earlier stage, where the ocean exists but remains hidden. If that is true, then Mimas is not just a candidate for life. It is a window into how possible habitats are born. And that may be even more important, because life needs time. A young ocean may not be alive, but it may be becoming more interesting. It may be developing chemistry. It may be interacting with its interior. It may be moving toward conditions that, in the far future, could become more favorable. Imagine Mimas millions of years from now. Saturn continues to pull on it. The interior continues to warm. The ocean remains liquid. The ice shell begins to respond. Cracks form. New terrain appears. Maybe one day the surface changes. Maybe one day material from the ocean finds a path upward. Maybe one day future scientists looking at Mimas will see signs that are invisible to us now. Or maybe none of that happens. Maybe the ocean freezes again. Maybe the energy fades. Maybe Mimas remains forever sealed, its ocean silent and lifeless beneath its ancient cratered surface. Both possibilities are humbling, because we are seeing only one moment in a long story. A moon's life unfolds over millions and billions of years. We are catching Mimas at one point in that story, trying to infer its past and future from motion, gravity, and a scarred surface. We do not know whether its hidden ocean is the beginning of something, the middle of something, or a temporary state that will vanish in geological time. That uncertainty is part of the beauty. Mimas does not give us easy answers. It gives us a question wrapped in ice. Could life exist there? The honest answer is probably not yet, if the ocean is truly young and lacks strong chemical energy. But the deeper answer is, we cannot rule out possibility in the long future. And the broader answer is even more powerful. Mimas proves that potential habitats can hide in places we never expected. That may be the real message of this moon. Not that Mimas is full of life, but that the universe hides its chances well. It hides oceans under ice. It hides warmth inside frozen worlds. It hides movement beneath cratered surfaces. It hides possibility where we once saw only silence. When you look at Mimas now, the giant Herschel crater is still the first thing you notice. It still looks like a frozen eye staring into space. It still carries the memory of an impact that nearly ended the moon. It still gives Mimas its strange Death Star appearance. But now, the crater is not the whole story. Beneath that scarred surface, beneath the ancient impact marks, beneath the frozen shell, there may be a dark ocean. And inside that ocean, perhaps, the ingredients of life are waiting. Water, chemistry, energy, time. The first two may be present. The third is uncertain. The fourth may have only just begun. That is where Mimas stands. Not as a living world, not as a dead world, but as a world in between. A world that reminds us how little we really know about the places that look quiet. A world that tells us the search for life cannot depend only on appearances. A world that began as one of Saturn's most overlooked moons and became one of the most surprising ocean candidates in the solar system. Maybe nothing lives in Mimas's ocean. Maybe nothing ever will. But the fact that the question can now be asked at all is extraordinary, because this was supposed to be a dead moon, a frozen, cratered, battered little object orbiting Saturn. And now, hidden beneath its ice, there may be an ocean, a young ocean, an ocean nobody expected. And in the story of the search for life, sometimes the most important discoveries are not the places where we find living things. Sometimes they are the places that teach us where life might be possible, even in darkness, even beneath ice, even inside a moon that looks completely dead. Mimas may never become the place where humanity finds alien life, but it has already done something almost as important. It has reminded us that the solar system is far more mysterious, far more active, and far more full of hidden possibility than we once believed. And somewhere, beneath the frozen face of the Death Star moon, a dark ocean may be moving quietly, waiting for time to decide what it can become. Mimas matters because it gives us two impossible stories in one tiny world. The first story is written on its surface, a crater so large that it almost destroyed the moon completely. A frozen scar carved by an impact powerful enough to send shock waves through the entire body. A wound that makes Mimas look like something artificial, something designed, something out of a nightmare from science fiction. But it is real. The second story is hidden beneath that surface, not visible in the crater, not visible in the old frozen plains, not visible in cracks, geysers, or fresh, bright terrain. Beneath the ice, Mimas may be carrying something no one expected from such a battered little moon. An ocean, liquid water sealed under a crust of ice inside a world that looked dead for decades. That is why Mimas matters, because it is not just one mystery, it is two. A moon that survived a direct hit and then somehow hid an ocean beneath the scar. Those two stories together make Mimas one of the strangest worlds in the solar system. It is small, cold, quiet, and easy to overlook. And yet, when we look closely, it begins to tell us something profound about survival, hidden possibility, and the way the universe keeps secrets in places we do not expect. The survival story begins with violence. The early solar system was not calm. It was not a peaceful collection of finished planets moving quietly around the sun. It was a shooting gallery, a place of collisions, broken objects, unstable orbits, and impacts so powerful they could build worlds or destroy them. Planets grew by impacts. Moons were shaped by impacts. Asteroids shattered through impacts. Crusts were melted, surfaces were erased, and entire bodies were changed forever. Every surviving world carries this history in some way. Earth does too. Our planet has been struck again and again across its long history. Some impacts were small. Some were enormous. One of the greatest collisions may have created the Moon itself, when a Mars-sized body struck the young Earth and threw material into orbit. Later, another impact helped end the age of the dinosaurs and changed the direction of life forever. Earth survived, but it was changed. That is the pattern we see across the solar system. Worlds are not untouched objects. They are survivors. They are shaped by what almost destroyed them. Mimas is one of the clearest examples of that truth. The Herschel impact should have been the end. It came so close to the limit that scientists look at the crater and ask how the Moon remained whole at all. The impactor was large enough, fast enough, and violent enough to nearly shatter Mimas into debris. But Mimas held together. Its gravity, its structure, its icy body, and perhaps a little cosmic luck allowed it to remain a moon, damaged, scarred, but still there. And that matters because it reminds us that survival in space is not clean or gentle. Worlds do not survive by avoiding every catastrophe. Sometimes they survive by taking the hit and remaining whole just barely enough to continue. Mimas did not escape destruction untouched. It escaped destruction marked forever. The crater became its face. The wound became its identity. The event that nearly ended it became the reason we remember it. In that way, Mimas becomes a symbol of cosmic resilience, not life resilience, not emotional resilience, not in the human sense, but planetary resilience. The ability of a world to absorb violence, fracture, deform, and still remain itself. To continue orbiting, to continue existing, to carry the evidence of disaster without disappearing. And that idea connects Mimas to a much larger story. The solar system we see today is not made of perfect worlds. It is made of survivors. Mercury survived the sun's early violence and countless impacts. Mars survived the loss of much of its atmosphere. Earth survived collisions, extinctions, ice ages, and global transformations. The Moon survived bombardment and still carries the scars. Saturn's moons survived the gravitational chaos of a giant planet and the constant movement of rings, debris, and neighboring moons. Every object that still exists is the result of a long chain of near misses, collisions, and recoveries. Mimas makes that truth visible in one unforgettable image, a small moon with a crater almost too large to believe. But the second story of Mimas may be even more important, because the ocean story changes the way we search for life. For a long time, scientists thought they knew which worlds deserved attention. Worlds with obvious activity, worlds with cracks, worlds with plumes, worlds with atmospheres, worlds with visible signs of internal heat. Mimas was not one of them. It looked boring. It looked frozen. It looked geologically dead. It looked like a battered ice ball whose most exciting moment had happened long ago. Then, the wobble revealed something else. Mimas was not behaving like a completely solid moon. Its motion suggested that the inside might be separated from the outer shell by a layer of liquid water, a hidden ocean locked beneath the ice. That discovery was powerful because it did not come from a dramatic surface feature. There were no geysers, no fresh terrain, no giant cracks splitting the crust. The surface gave almost nothing away. And that is the lesson. Appearance deceives. A world can look dead and still hide movement inside. A frozen surface can hide a liquid interior. A cratered moon can hide an ocean. This changes the meaning of every icy body in the solar system. If Mimas can hide an ocean, then we have to ask, how many other worlds are hiding oceans too? How many small moons around Saturn, Uranus, or Neptune have interiors we have underestimated? How many frozen objects in the outer solar system have been dismissed too quickly because their surfaces looked quiet? Mimas is not only important because of what it may contain, it is important because of what it forces us to reconsider. The search for life beyond Earth used to feel focused on planets like our own, rocky worlds, warm enough for liquid water on the surface, orbiting at the right distance from their stars. But the outer solar system changed that. Europa showed us that an icy moon around Jupiter could hide an ocean beneath its crust. Enceladus showed us that a tiny moon around Saturn could have a global ocean and spray material into space. Titan showed us that complex chemistry can exist in ways that do not look like Earth. Ganymede may contain deep layers of water beneath ice. And now Mimas, one of the least likely candidates imaginable, may join the family of ocean worlds. This is the ocean world's revolution. It tells us that habitability may not always look like Earth. It may be hidden. It may be dark. It may be sealed beneath ice. It may be warmed not by sunlight, but by gravity. It may exist on moons that, from the outside, seem cold, dead, and forgotten. That is why Mimas matters to astrobiology, even if life is unlikely there today. Its ocean may be young. It may not have had enough time for life to emerge. It may lack the right energy source. It may not have the chemistry needed for biology. We do not know. But the fact that the question can be asked at all is extraordinary. A moon once considered boring now belongs in the conversation about hidden habitats, and future missions could change everything. No spacecraft has ever gone to Mimas specifically to study its ocean. No lander has touched its surface. No probe has drilled into its ice. The data we have comes mostly from missions designed to study the Saturn system as a whole, especially Cassini, which gave us a new way to understand the Moon's movement. But now, the calculation changes. A future mission to Saturn might not ignore Mimas the way older mission plans might have. A dedicated orbiter could study the Moon in far greater detail. It could measure its libration more precisely. It could map its gravity field. It could study the thickness of the ice shell. It could search for subtle surface changes that earlier images missed. It could ask the question directly, is there really an ocean under Mimas? And if there is, how deep is it? How thick is the ice? How young is the ocean? Does it touch rock? Does it contain salts? Does it have chemistry that could matter for life? A future spacecraft might fly close again and again, building a detailed map of the Moon's interior, from gravity, motion, and surface observations. It might use radar to study the ice. It might look for tiny variations in the surface temperature. It might search for cracks so subtle that Cassini could not reveal them clearly. And perhaps one day, much later, a more ambitious mission could attempt something even harder, reaching the ocean directly. That would be extremely difficult. Mimas's ocean, if present, is hidden beneath tens of kilometers of ice. A lander would have to survive the journey to Saturn, land on a small icy moon, operate in extreme cold, and somehow penetrate deep below the surface. The technology would be closer to the concepts imagined for Europa or Enceladus than to any simple lander we have built before. A probe would need to melt or drill through the ice. It would need to avoid contamination. It would need power, communication, and a way to send information back through the ice to the surface, then from the surface to Earth. This is not something that will happen soon. If it ever happens, it may belong to the 2040s, 2050s, or beyond, maybe later. Space exploration at Saturn is slow, expensive, and difficult. Missions take years to arrive. Technologies need decades to mature, and Mimas will have to compete with many other fascinating worlds: Europa, Enceladus, Titan, Mars, the moons of Uranus and Neptune. But Mimas has something unique. It may be a young ocean world. That could make it scientifically priceless. If the ocean really formed only a few million years ago, then Mimas may preserve a rare stage in the life of an icy moon. Not an ancient ocean that has been active for billions of years. Not a mature ocean already breaking through the surface, but a young hidden sea, perhaps still in the early stages of chemical evolution. That could give scientists something they almost never get: a snapshot of possibility near the beginning. What chemistry happens when an ocean forms inside an icy moon? How does water interact with rock in the early stages? How quickly do complex molecules appear? How long does it take for an ocean to change the surface above it? Could prebiotic chemistry begin in a place like Mimas, even before life exists? These questions matter far beyond one moon. They matter because they may help us understand how habitable environments begin, not only on Mimas, but across the galaxy. If the universe is full of icy worlds, then the birth of hidden oceans may be common around giant planets, around distant stars, maybe even on rogue planets drifting between stars. Water could be sealed beneath ice, warmed by internal heat, protected from the violence of space. Some of those oceans may be old, some may be sterile, some may become alive. Mimas gives us a chance to study a place that may be early in that process, not proof of life, but perhaps proof that the first conditions can appear in unexpected places. That may be the deepest reason Mimas matters. It teaches humility. Every time humans think we have sorted worlds into simple categories, the solar system surprises us. Mars was once thought to be dry and dead. Then we found evidence of ancient rivers and lakes. Europa was once a point of light. Then it became an ocean world. Enceladus looked too small to be active. Then it erupted into space. Pluto looked like a frozen leftover. Then new horizons revealed mountains, plains, and complexity. Now Mimas joins that pattern. A moon that looked simple becomes mysterious. A dead surface hides a moving interior. A scarred body becomes a possible ocean world. The lesson is clear. Do not judge a world only by its surface. The universe is very good at hiding its most important secrets under ice, dust, shadow, and time. Mimas is small, but its message is large. It tells us that survival and possibility can exist together. The same moon that nearly shattered may now contain liquid water. The same body that wears a crater, like a wound, may be changing inside. The same world that looked finished may be quietly beginning a new chapter beneath its frozen shell. That combination is rare and powerful. A survival story above, an ocean story below, past destruction on the surface, future possibility in the dark. When we look at Mimas, we are looking at a moon shaped by catastrophe, but not defined only by catastrophe. Herschel crater tells us what happened long ago. The hidden ocean tells us that the story may not be over. That is the emotional power of this little moon. It survived the kind of impact that could have ended it. It carried that scar through millions and billions of years, and then, quietly, without geysers or dramatic announcements, it revealed that beneath the damage, something may still be moving. There is something almost poetic in that. A world can look broken and still have depth. A world can look dead and still contain water. A world can look like a symbol of destruction and still become a symbol of possibility. Mimas matters because it changes how we see the quiet places. Not every important world announces itself with volcanoes, storms, rings, or glowing atmospheres. Some important worlds are small, pale, cratered, easy to miss. Their secrets are not written in bright colors or dramatic eruptions, but in tiny motions, slight wobbles, and patient measurements. The solar system is not only full of famous worlds, it is full of hidden ones. And Mimas may be one of the best reminders that discovery does not always come from looking where everyone expects. Sometimes it comes from looking again at the thing we thought we already understood. Tonight, as you drift towards sleep, imagine Mimas moving quietly through Saturn's ring system, a tiny icy moon orbiting a giant planet in the cold outer solar system. On its surface, the Great Herschel crater stares into space, a scar from an impact that almost ended it, a wound so large that the moon looks like a machine made for destruction. But it is not a machine, it is not a weapon, it is a survivor. And beneath that scarred surface, beneath kilometers of ancient ice, water may be moving, dark, silent, hidden, an ocean that may be young in geological time, an ocean that formed while Earth was already full of life, while evolution continued across forests, oceans, and plains, a secret sea born inside a moon no one expected to be active. Mimas survived the hit that should have destroyed it, and then, when nobody was looking, it may have grown an ocean. That is why this small moon matters, because the universe never stops surprising us, because survival can hide beneath scars, because possibility can hide beneath ice, because the most astonishing worlds are not always the loudest, the largest, or the most beautiful. Sometimes they are the quiet ones, the overlooked ones, the frozen ones, the ones hiding in plain sight. Somewhere near Saturn, Mimas is still orbiting, still scarred, still carrying the memory of impact on its face, and perhaps deep below, still carrying a dark young ocean that may one day teach us where life can begin. Good night.